What am I supposed to do with it?
Open it up.
Oh, open it.
Yeah, isn't that how it usually
There's
goes?
a piece of paper inside.
Yeah. Sometimes.
It's got letters on it,
Uh-huh.
and the letters look like they make words.
Okay.
And the words say, well, the first one's a letter, the capital A. Ah.
Okay, you're really drawing this one out
Yeah.
there.
A perfect deck doesn't exist. It looks like it's a statement, not a question.
statement.
Yeah, that's a statement, yeah.
Okay.
I agree.
Well, yeah.
Why do you agree? What are the problems
I've never
with
heard
decks?
one. Have you?
Well, nothing
Okay.
perfect exists.
Okay, that too, but I've never heard a perfect deck.
So there's a few parts to this one. Most people think it's a DAC, they're all the same, it converts digital to analog, digital is perfect. That's kind of the general consensus on what people think, right? And now there are some people that have a little bit more in-depth understanding. You can see some of the nuance and the challenges with digital. But for the most part, people perceive digital as being perfect or near enough perfect for human audio use. Because of course, your ears have finite resolution. You know, they're not getting better, and most people, I would imagine, would think of digital as good enough. The cheapest dumpster fire DAC you can get is fine.
Does your cat like music
No.
sometimes? Not at all, yeah. Maybe you're playing it too loud.
Well,
They're
maybe.
very sensitive. you know.
Yeah.
How does this relate to DACs?
I don't know. You said humans listening, so I figured I'd bring up a cat.
Okay. Well, humans happen to have a pretty finite ability. I mean, our hearing isn't going to get significantly better in the next 50 years or 100 years. That's pretty
Actually,
unlikely,
it's known
right?
that it gets worse, and it's
No, it's just saying humans in
No,
general.
I'm saying in general.
Oh,
humanity.
overall.
Evolution
Like
is
you-
not going to be like,
You look at technology.
Yeah, we don't have a reason to.
yeah, no.
If anything, we got a reason not to.
Okay,
get
it's
it.
not going to happen in 50 years.
Yeah. No.
Okay. Whereas in 50 years, you look at what happened with technology. Pretty big difference now from 50 years ago.
Sure.
Okay. So you extrapolate that out. At some point,
In
everything's
terms
amazing.
of playback, you mean, or
Relative to a human's abilities, the cheapest thing you can get is amazing. And I think a lot of people feel we're kind of already there,
yeah,
especially with digital audio, because it seems so basic and simple. You look at a smartphone, there's really not the reason you used to have to get a new replacement.
Right.
They're not that old, too. It's like they haven't been around for 300 years.
yeah.
No.
You know,
10.
07,
Yeah.
08 are
Yeah.
maybe kind of
Yeah.
somewhere around there.
Yeah.
Depends on when you define it. But it hasn't been that long, and we're at the point now where most people are like, I don't really need a new one.
Well, I remember when this whole digital thing first came out, and everyone thought it was thought it was going to be perfect.
Right.
You know, except the analog guys, of course. The vinyl guys are like, when they, you know,
Well, still
they
are.
doubted it right from the beginning, and they still do. Yeah.
Yeah.
There's so, but yeah, I know when the first CDs came out and stuff like that, it did sound different. It sounded cool. It sounded clean. It was
No
probably
pops. Yeah.
Yeah.
it was
It's
probably
different.
more even across the board in terms of everyone kind of heard probably a similar type of sound from
Yeah.
a disc versus
Yeah,
like
a lot
the
more
turntables
consistent.
are so
Yeah.
wildly varied depending on cartridges and stuff like that. So maybe the low cost turntable end of things back in the day all sounded the same, but I don't think so. I think even that varied a lot.
Maybe.
You know, but yeah, this gave more to me when it first came out. It was more of an even playing field, and I do remember that it was pretty cool to listen to because it did seem, in terms of frequency response, it did seem to trump my mediocre turntable setup I had. You know, probably $102 turntable, nothing exciting with
Yeah.
some shitty speakers, but it had this clarity to it that I never heard out of my albums. You know, but obviously as time goes on and the speakers evolved,
Yeah.
because there was no resolution on the speakers I was using in the early 80s, this whole digital thing started to get a little annoying, I think, for some people, particularly the analog, the guys who are from...
Well, why don't we skim over the common challenges with digital? Because a lot of people, they think, well, I plug it in, it works. And it either works or it doesn't effectively. So what's the deal? What's the difference a DAC could make?
The ones
or
and
whatever?
zeros argument type thing?
Right, just from a higher level, I guess. We'll have a little summary. So digital, right? Typically you have active high, active low, identified as 1 and 0. Doesn't really matter what the voltage is or what it is, right? It's just, there's a high signal and then a low signal. That's a 1 and a 0, effectively. That's the most common use. Obviously you could go more complicated than that. But there's a lot of nuance to that one because you can't accelerate this voltage from 0 to whatever positive 5 volts instantaneously. There's always a finite amount of bandwidth a cable can convey because of all kinds of reasons. And so the rate of acceleration is never perfect. It's
Not
never
only,
perfect
not only
vertical
the
line.
cable, you're assuming that you have an external
PCB doesn't matter what it
source.
is, right?
Yeah.
Like internal signal, whatever. The conveyance of the digital.
Even if
from-
you're reading it right off a disc right inside the player.
Sure, there's wires connecting the little laser read head on a CD
Yeah.
to all the different things. Everything has some sort of cables or conductors of some way conveying the information.
Well, the chipset also, the DAC itself also has thresholds it has
Yeah,
to see in order to
right.
consider what is a 1.
That's what we need to
versus
skim
what
over,
is a
right?
0. Oh.
And so when something in this circuit, the DAC or whatever, the output device decides, hey, I want to shoot out a 1 now, it needs to put this voltage on this, whatever this wire that goes to the DAC chip or outputs to a different external DAC or whatever, it needs to bring that up high. And it can't do that instantaneously. And so it rises at a rate that's never perfect. And yet, when it first started to rise is when it actually wanted to be identified as a 1, effectively, right? So it's always a bit of latency there, there's a little bit of lag. And then when it shoots up at the top, it can't stop instantly either. So you get ringing, you get overshoot, and it's challenging to have perfect, reliable identification of when the 1s and 0s start and stop.
That's assuming you need perfection in order to reproduce the music.
You don't. You need repeatability.
Yeah.
But that still doesn't occur for all kinds of reasons,
Yeah, it wasn't that long ago they came up with this thing called jitter.
right?
And before that, like I said, you refer back to the analog guys, they heard it. They knew that it was messed up and there was something wrong. And it was a variable. It just depended
Yeah.
on what DAC you were using or whatever, and no one could pin it down because there was no measurement for it. And then
Sure.
someone realized that there
Yeah.
were, I guess its phase or timing differences were causing kind of what that is, where the signal skewed from when it actually
Right,
should have
yeah.
played to when it actually did play. I guess we're simplifying this, obviously.
There's a lot
But-
going on.
Yeah.
Yeah, it's pretty complicated
But,
stuff. We
yeah.
certainly don't know it all.
Yeah, right. And
Yeah.
and trying to explain it would take a book. But yeah, bottom line is that they found out, when they measured it, they found out that, wow, there was huge variations where, went to thousands of picosecond variation from when the sound should have occurred to when it did,
Sure.
when it really should have been under 100 or in the hundreds. And so it was a many factor.
I think the
off,
important
which is
thing-
it blurred the sound, so to speak. It just made it sound.
The important thing to get across
Screwy.
is digital is never perfect. It never will be perfect. You can't convey digital perfect because that would mean infinite bandwidth. That, as far as we know, doesn't exist, right? There's
Where-
always challenges to digital.
There's obviously technical guys that don't really know the total inner workings of a DAC, but they'll argue, all the time about the fact that it is perfect, that it's
Right.
1s and 0s, and
Doesn't matter.
what could go wrong. But where the way I understand it, to simplify this, where it all goes wrong is at the conversion process itself. The digital side of it, the 1s and 0s, is always the same. Like the file, let's say we're running a file, like a song file.
Yeah.
Right? It's the same. The data is the same.
Well, yeah.
A
Otherwise, it
CD,
would sound different
the
every time you
CD
play
the
it.
CD, the data is the same, although you can argue that reading off a CD with light can cause other issues too, which it does, vibrational and otherwise. But let's just say data file, just a file with bits, 1s and 0s, right? It's the same. It's always the same. You're streaming music. The bits are, for the most part, the same. Doesn't matter
Yeah.
where you stream it, who it is, where it goes, right? So that end of it's not part that's getting messed with. There's no one arguing
Right.
that digital side of it's the issue. The issue is right where it goes and converts to analog.
Well, yeah, you can't
That's
hear
when
digital.
things go wrong, and that's where the variations occur.
Yeah.
And and there's a number of reasons. You've got power supply noise causing issues, causing the DAC to false, or not necessarily see. If you got noise riding on the signal, the incoming digital signal, it causes false pluses, false 1s, false 0s. It just depends on how good the DAC is.
Well, it could skew timing as well.
It
But
is
yeah,
good,
right.
sure. I mean, you've got also noise can come from external factors, RF, through the AC cables, through if you're running a digital cable from a source or something, you can get noise entering into that. But those type of things are getting at the DAC and causing an effect that when it's trying to convert this signal, it's audible. It's an audible effect.
Yeah.
And it's right at the conversion process. And, that's why a lot of people, I think, too, see differences with different inputs, like we were talking in one of our earlier
Right.
videos, where, optical versus RCA SPDIF versus blah, blah, blah.
There's all kinds of pros and cons, but
Yeah.
a couple of people mentioned Ethernet, which is one I believe we
Yeah, we
forgot
didn't
to
even
mention.
cover that.
But
Yeah.
that is a somewhat more
Yeah,
common.
Yeah, you see that more in the
That's
modern
higher end
streamers
stuff.
now.
Yeah, right.
Yeah, which that's kind of good. That's made to run
Right.
digital. At
That's
really
working
low
on a
latency.
foundation that's very well
Yeah,
proven
absolutely.
at this point.
Yeah, and good for rejecting noise and
Yeah.
stuff like that too.
Yeah, has to be at this point.
Although the funny thing is, I still, even though technically speaking, that format, like if you're running like a Cat6 cable in, shouldn't matter what the cable is. I've never really compared cables, but I know a ton of people have told us that the cables, those cables make a difference. The Cat cables make a
Right,
difference
yeah.
as to how they're produced and made. So
Don't have a stream.
even though it's not supposed to, and at that point in the digital stream, those ones and zeros are supposed to be identical. For some reason, I would assume that somehow noise is still transferring through the system through those cables. And again, it's one of those that they're supposed to be like, what are they, galvanically isolated? What's the isolation on the Cat cable side of it? Do you know, coming in?
Galvanic,
Yeah, I mean, there's no ground reference,
right?
right? So
Differential.
yeah, well, okay, so it's like basically balanced.
Yeah.
There's no ground reference, right? But how's it rejecting noise coming in? How's it keeping? I mean, it's just a bunch
Differential
of
signal
four
pairs.
twisted pairs coming in and out,
Yeah.
right?
Yeah.
How's it? It's just a differential, right?
Yeah.
So see, in that respect, it's not perfect either.
It's never perfect.
Yeah, you're assuming a perfect balance on every twisted pair, and that assumes the pairs are twisted perfectly all the way. The
Yeah,
cable's
they're not
kinked or
always.
bent
Yeah,
anywhere.
but the argument could be
Yeah.
made that these things don't matter because the data always ends up
Getting there?
on the other end, and it does.
But it's what's riding with the data on the cable is coming into the device.
Right.
And the other problem is high frequency energy too. That bleeds through whatever they're using for isolation. It's going
Right.
to bleed through. You got capacitor, you got parasitic capacitance. You always do, And so as much as you try to avoid it, the high frequency energy that's riding on that for whatever it is, whatever's in the home,
Yeah.
whatever it's picking up. Again, these things cause the DAC to false. It can cause timing errors.
Well, jitter is pretty much what you're getting at. That
Yeah.
seems to be the primary
But
issue.
it can be audible.
yeah.
And so
oh, yeah.
these are the things,
Very
though,
much.
where the environment is a part of the problem. And, therefore, it's difficult to say that it could ever be perfect. Digital could ever
Right.
be perfect,
Well, it's just the challenge is it's a high frequency rate.
When you
So,
convert it to analog.
Yeah.
It's fine if it's going into another digital device.
When this
It's
single's
as long as
moving-
digital stays digital. It's long, but at the conversion process to analog is where it goes.
It's a bit more
where-
complex
where
than that,
things
but
get
typically
wrong.
that's where most of the impact is.
Yeah, well, I'm not saying you can't.
Digital's-
I can't say,
Yeah.
I'm saying don't script digital.
I think the summary to get across is digital isn't perfect. It's never perfect. Now, people interpret it as since the data always ends up perfect on the other end, that it must be fine in the transmission. There's no challenges in transmitting digital. But there's a great deal of challenges. And the only reason why it ends up correct on the other end is typically because there's some error correction or
Right.
detection
Well, sure.
process.
It's made to accept errors and,
Right.
and correct for them.
But things
Yeah.
can be a bit more challenging when this has to be done in real time. It's like the difference between a VoIP call and a video playback that's buffered or something like that. Like VoIP, you got to have real time internet connectivity. Otherwise, you lose you drop frames, you drop packets, you lose some portion of the call and the audio drops out. Like if you ever had any streaming service or whatever.
Was that just due to a lack of buffering or something like that? or-
Well, you can't buffer it because it needs to be real
Oh,
time. Right? You
right,
can only
yeah.
buffer it so far.
Right, yeah, right.
Like when you do with any real time service, if you have buffer, it adds latency. And
Yeah.
so how much are you going to buffer? A second?
Yeah,
Because
right.
now everything you say is a second
Yeah,
back.
and then
it's really
so you can
hard
only
to
have a
talk.
tiny little buffer. And so that's the challenge. You could only have a itty bitty little buffer. And
Right.
it depends on your connection latency too.
There's
But
a balancing act, right?
there's a real balance. But yeah, you could only do so much there. It just pretty much has to be, it always has to arrive perfect. And if it doesn't, too bad. You don't get it. And there's a lot of services that are like that, like gaming and stuff like that.
Yeah, gaming.
Yeah, like if you're sending information that this player moved this distance over here, they're now looking at they shot there, it needs to happen in real time, right?
Yeah.
If it's not received, you can't be like, oh, this happened 3 seconds ago and update this guy
Yeah.
that already did a different thing.
Yeah.
It's the same thing,
I
right?
get that like on the TVs in the house. Every TV's got a different. If you got 3 TVs running to play the same station,
Yeah.
got the guy.
They're in different spots.
Yeah, the sound's totally different on each 3.
Yeah.
Yeah.
A pretty decent delay between
Yeah.
the two.
It can get pretty
Some
bad.
could be
Yeah.
significant,
Yeah. So
right?
and that's basically digital coming in and
That's because it's buffering.
Yeah.
But there's a lot of surfaces you can't afford to buffer
But I
because
mean,
you can't
people
afford
don't
the
think about that, I
delay.
guess, that electronics are actually slow. I
Right.
mean, in that conversion process, even within like something as simple that you can relate it to a TV, that conversion process does have inherent delays.
Yeah.
Well, nothing's
Like you
instantaneous.
said, now nothing's instant, including the signal itself.
Right.
But
But
yeah.
if there was a buffer in your DAC that was actually considerable enough to guarantee identical reproduction, there would be a considerable delay. Like when you press play or something like that, they would have to play, would have to stream some and buffer it, make sure it's all correct before it would play
The
back.
video's delayed too, isn't it? A bit. I mean,
And even then,
that
internally,
is
it needs to
delayed.
replay
Well, yeah.
back this digital.
Processing and
Everything's
such.
always delayed. Yeah, it's just a question of how much.
How much? Yeah. Some things are really bad, but
Yeah,
it's a whole different thing.
and that's
Yeah.
again still
Yeah.
it starts at digital with it as a digital signal, the video and the analog.
There's a lot of
Everything's
handshaking
digital.
going on now, HDMI and all that. You know,
Yeah, and I guess the TVs are also processing.
processing. Yeah.
They're doing a lot of pixel counts and playing with the picture and making
Yeah.
things look as good as possible, upsampling.
Right.
Yeah.
So,
There's a lot of huge,
denoising and all
a lot of
that.
latency on.
But that's done
most
in
TVs.
a digital main. But I guess that's
Yeah.
where
Yeah.
the delays occur.
But still, all these issues we described are happening internally in the TV, even if it's buffered. If it's buffered, all it means is this digital information is stored somewhere, but it still needs to be effectively played back and output still into something that converts it into analog or different type of data.
It's got to be a noisy situation inside a TV. I mean, really noisy. You know, it totally limits the res. I come out of a TV. I tried the new Sony. I got the 77-inch. Right? It's got a headphone jack somewhere on that big rear end of it.
Oh yeah, you tried
So,
it?
Yeah, I'm coming out a headphone through a long interconnect into my
Pathos?
headphone amps. Yeah, the
Yeah.
headphone amps, and there's just not a lot of resolution there.
Well, yeah.
It's just dull.
It's-
It's dullish. It's like they purposely got to dumb it down
Like-
just to make sure you don't hear a hum, noise, a buzz. You know?
I'm sure it's
I mean,
not a top priority.
It's not bad, but it's just like it's like
Yeah.
Jesus, I could do way better than this. Just give me an HDMI cable going into a receiver and plug into that with a headphone or something. You're still better off. So
I think a big part of the challenge now is the worst DACs you could get are pretty good. They're fine. They're not terrible. They're just okay. But we're operating in a space where you strive for excellence. You strive for as close to perfect as you could get. People want to hear something as good as they could get, and that's why they're buying multi-$1,000 headphones. So you're not going to be happy with the DAC chip that's built into your little phone dongle or something like that. Like, 'cause it's
not if you're accustomed to the high end stuff.
it's
Yeah.
okay, it's
I mean, clearly
fine.
it'll work
It produces
fine.
audio, it sounds decent.
Yeah.
It's not like it was back in the day where you could get something that would be absolutely appalling relative to the high end.
Now the opposite is true too. Like on the high end of things, the designers of this expensive stuff. We're talking like Meitner and these guys that have done $10,000-$15,000 DACs. They
Yeah.
come up with a lot of novel ways to deal with these situations where they've
Yeah.
pieced together what they needed to do to make this digital sound better
Yeah.
through the analog conversion process.
Right.
I'm not privy or understand. I don't read up on this stuff of what they do.
Sure.
Most people come up with buzzwords for marketing, but bottom line is they've all got their secret sauce, so to speak, of how to avoid these pitfalls in the D to A process, and make it sound as clear as good as possible. But
Yeah.
you pay for all that. It's they're putting in some crazy amount of regulated power supplies in the thing. Separating power supplies for the different chipsets. The analog's got a different power supply from the digital side, and paying attention to trace lengths, like you were bringing up with traces and stuff like that. I mean, you can get pretty heavy with that.
Of course, another one to always bring up that seems to be
Optimizing it.
forgotten is in a DAC, there's an analog output. And so you still have effectively an amplifier, an analog amplifier built into it as well. And if people are aware that analog amplifiers, they make a difference in sound.
Yeah.
I mean, it's not like totally night and day, like the difference
can
between
be.
airline headphones and
Yeah, well,
$1,000 headphones.
It can
But
be.
it's noticeable.
I bet
and
if
that's
you-
still built into a DAC.
I
So
bet
that's
if you
still
were able to
happening.
tap right off the DAC chip, it'd sound way different than coming right out of a DAC through its analog section.
Yeah, if you isolate
if
before
if you were able to
it
have
gets
your own
amplified, yeah.
output stage or something like that,
Right.
yeah, you could see how much that could vary. Because that's one of the
There's no
arguments-
way to know.
That's one of the other arguments where everyone's saying, well, all these DAC chips all the DACs sound the same. A DAC is a DAC type thing,
Right.
And it really is about implementation at that point. It's not just a chip. If you could
Oh, yeah.
just use a chip and hear music, wonderful. Have at it.
Yeah, open up a
But-
modern DAC. They're a bit more complicated than
there's,
just a chip.
Yeah, I mean, there's, you got to deal with power supplies. You got to have a
Right.
buffer stage. You got to have a way to bring the signal in without screwing it up, without
And out.
let noise transfer into the signal. So yeah, in out. So yeah, I mean, so I mean, the guys that thought this out, you look at the higher end DACs, they're really complicated.
Yeah.
I mean, sure, you could put it all on a chip on a board with some surface
Absolutely.
mount
Yeah.
devices.
Right.
Look at your phone.
Yeah, or your,
Right.
yeah. I mean, yeah, you can miniaturize this into one chipset, no issue.
Yeah.
But if you really wanted to optimize like these guys do, it's a lot involved.
Right.
A lot involved. So anyway,
There's a lot more
it's
complications
not perfect.
than most people perceive. There's a lot of stuff going on. We only kind of vaguely glossed over it. We're not super familiar with DACs. We don't make DACs, but
How does a transporter work in Star Trek? That's kind of like an analog to digital converter.
it's the same
isn't it?
thing, yeah.
Yeah, and then
Yeah.
it goes the other
Well,
way.
they
at
kind
the
of just
other end.
made stuff up, like the Heisenberg uncertainty principle. They just kind of
Yeah.
made a thing that fixes that.
I don't know, a lot of stuff they make up tends to actually wind up flushing out 50 years later. You know what I mean?
Oh, well,
Some of the
yeah.
stuff that's on Star Trek, they're starting to use like, I don't know.
Yeah, well,
the
we're not there.
terminology is being used like
Well, yeah.
warp drive, right? I mean,
Yeah.
that was real.
Yeah.
Yeah.
Well, we're not
I
there
never
on
looked up
transporters
Heisenberg.
yet.
Did you?
Well, yeah.
Is he a German guy that did something?
Something like that.
He did a thing, yes.
Yeah. But anyway, yeah. I mean, so they managed to figure out how to at least in a sci-fi, transport a human between two different spaces, and that's quite the conversion process. So
That it is.
Maybe at that point, digital has become perfect, or perfect enough,
Near enough.
where the couple pieces in your body you miss
Oh,
really
yeah.
matter.
Yeah.
Well, that is the reality, though, because we're dealing with finites,
Yeah.
Yeah.
right? Your perception of hearing isn't going to change appreciably in the future, and the data that makes up you, that's not going to change much in the future. So theoretically, you're approaching something that's finite, which gives you a little bit higher confidence that we could have something that's relatively perfect.
Yeah, we're close enough.
Right. It's not a moving target, so it's more achievable than not, maybe, kind of.
Then again,
Sort
what
of.
is perfect? And do you really want perfect?
Depends who you are, I
It
guess.
seems beneficial if you're trying to transmit
I don't know.
person information to a
'Cause
different
we're-
Yeah,
place
yeah.
to be
Yeah,
recreated.
yeah, yeah.
'Cause
Definitely transporters. I want them to be
Transporters,
perfect.
yeah,
you
you
don't
wanna
want to
be
start.
pretty
Yeah,
good,
yeah.
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 It'd miss a few things here.
Yeah,
Right.
yeah.
Your arm's
That would
missing.
add up over time.
It has happened
Yeah.
in the show.
In fact, in the show, when they go wrong, yeah,
Yeah,
you start-
it's
you
bad.
start
It's still not
really-
It's
perfect.
bad.
There you go.
Yeah.
It's bad.
Yeah. Remember
So,
when
yeah.
Scotty was stuck in a transport buffer with a
Yeah.
bunch of people and they found him? Was that Relics? Was it
Relics,
called?
yeah.
Yeah, that was a good one.
Mhm.
Yeah. And what was the name? The dude's name that didn't make it. He was under 50%? Was under 50%? He degraded.
Yeah,
his-
there was a lot, like whatever it was, the percentage. I was like, that sounds like way
I think it
more.
was like 50-some% or something.
Than
yeah.
you would think.
Yeah, and they
Like-
couldn't recover him.
Yeah.
They couldn't bring him out of the transport buffer. Yeah. So
Dang.
they have a threshold where
Mm.
you still come back alive.
This is like
I don't-
space future
Yeah, I don't
technology.
I don't know what
so
kind
it's
of
pretty
pieces you're
good.
missing, but
Yeah.
at some point they could still
They're
bring
like,
it in.
we could try.
Yeah. But I guess at some point it's damaging.
Well, they'll have to work on that.
Yeah.
Yeah, got a long way to go.
Yeah.
Same with the DACs. And they're working on it. But yeah, I have yet to hear a perfect one because the reason I know is because they all sound different. So
Well, you
if
need
they
a
were all
perfect-
they'd all sound the same.
You
right?
would need a perfect amp too, though,
Well, that's
to
true.
hear the perfect DAC.
Well, that's
so
true.
that's
But-
and then you need a perfect headphone.
Well,
or
that's
a
true.
perfect
But
speaker.
given that everything else is a constant,
Well, yeah,
right?
yeah.
I've never heard two DACs sound the same. So I guess
It seems possible one day we could arrive on a target where everybody has very uniform performance that's near the limit of human ability, and it's in a tiny little chip that you can integrate into a device for pennies.
Well, anyway, thanks for watching this one. Interesting topic, and I know it's kind of controversial with a lot of people, but
Yeah.
it is what it is. We appreciate the sound of DACs and stuff like that and equipment, so we're kind of coming at it from I come at it at least from more of a subjective side in that I've never heard the perfect DAC, like I said. And anyway, I'm rambling. I don't even know. So anyway, thanks for watching, and please give us a thumbs up if you like this video. And by all means, subscribe because we'll just keep them coming. Thank you. Take care.